Hey guys, this is for my class for Wednesday, February 17th, and also the Thursday class, February 18th. So we're going to start out by finding the greatest common factor from a set of terms. So these first few problems that I have on the presentation come straight out of your book, pages 69 to 72. So last week we did practice finding the greatest common factor, I think, with two terms, but this time we're going to have more than two terms. So remember that multiples are large numbers and factors are small numbers. So normally you wouldn't, need to list the factor of 1 because every number can be divided by 1. So after this first problem, we'll skip the number 1, but for this first problem, we'll go ahead and say one of the factors of 30. Well, two of them are 1 and 30. What else? 2 and 15, 3 and 10, and 5 and 6. So 45 would be 1 and 45, 3 and 15. What else? 5 and 9. Oh, sorry, my pen does that every now and then. And then I believe that's it. I'm pretty sure that's all. But then the third one, 73, is a prime number, which means it only has two factors, which is 1 and itself. So the reason I started with the ones is because we found out that the greatest common factor of these three numbers is in fact 1. They don't have any other common factors, which you'll find every now and then. But here we're going to start adding some variables. So you want to think of what is the biggest number I could divide 20, 15, and 10 by, and also the variables we'll talk about in just a second. So normally, instead of listing them all out, I'll start with the smallest number. And the first thing I want to know is, will 10 go into the other two numbers? Well, 10 will go into 20, but it won't go into 15, right? So then the second biggest factor of 10 is 5. So I know I can divide 10 by 5, 15 by 5, and 20 by 5. So 5 is the greatest common numerical factor. And then we want to see what is the biggest number of x's all three terms have in common. Well, this has 4 x's, this one has 3 x's, and this one has 5 x's. So how many could I take out from all three of them? Well, I couldn't take 5 x's out of this group. There's only 4 of them. But I could take 3 x's out of each set of numbers or each term. So x to the third is the greatest number of x's I could take out of all three terms. And then 2 of my terms have a single y. One of them has y squared. I couldn't take 2 y's out of this one, right? So y goes along with my answer. You're going to have to forgive my pen. I don't know why it does that every now and then. 5x to the third y is the greatest common factor of all three of these terms. All right, let's look at the next one. So our smallest number is 100. Would 100 be able to go into 250 and 150? No. So then the next biggest factor of 100 would be 50. I could divide 100 by 50. I could divide 250 by 50 and 150 by 50. All right, so 50, we're going to start out with 50. And then there's 1x, 3 x's, and 2 x's. So how many could I take out of each term? Well, because of this one, only 1x. And then also we have 1y, 2 y's, and 2 y's. So 1y is the largest number of y's I could take out of all three terms. So my greatest common factor is 50xy. All right, what about this one? So the 16 can be divided by 8, but 20 cannot be. So then my next greatest factor of 8 is 4. So I can divide 8 by 4, 16 by 4, and 20 by 4. And then I have 3 A's, 4 A's, and 2 A's. So 2 is the smallest amount of A, the largest amount of A's I could take out of all three terms. So my greatest common factor is 4a squared. Number 5, what are the factors of 26? So 2 and 13, right? And I think that's it. And then 39 would be 1 and 39, 3 and 13, 3 and 13. So I'm gonna bet that probably 52 is divisible by 13. So when I divide 52 by 13 on my calculator, it is. So 13 is my greatest common factor. And then the greatest number of A's I can pull out is 1. And the greatest number of B's, I have to get the smallest one. So my greatest common factor is 13AB. And then number 6, let's see. I know both of these numbers are divisible by 5. I'm thinking of a bigger number, 9. 75 can't be divided by 9, but I think 15. So I know 3 times 15 is 45. Is 75 divisible by 15? It is. So 5 times 15 is 75. So 15 is the biggest number. Both of them can be divided by. And then I have 1x. I have to use the smallest one. And then both of them have a y squared. So I could bring out a y squared out of both terms. And then I could bring out 2 z's from both of them. And so that is my greatest common factor. All right, now I believe we're gonna start factoring. Yes, that's what we're gonna do. So first of all, a trinomial is just an expression with 3 terms. So I am going to factor this trinomial by dividing each term by the greatest common factor. So I'm looking at -4, 20, and -16. I know I can divide all 3 of those terms by -4. All right, what's the biggest number of x's I can pull out of all 3 of them? They each have x to the 2nd power. And then this one doesn't have a y. So I'm not allowed to bring out a y up from any of them because I can't do it to all 3 of them. So I'm literally going to divide -4x squared y squared by -4x squared. Well, -4 divided by -4 is 1. X squared divided by x squared is 1. So all I would have left if I divided the first term by this greatest common factor is y squared. And 1 times y squared is y squared. All right, 20 divided by 4 is -5. X squared divided by x squared is 1, and 1 times 5 is 5. And then I didn't get to bring out any y's, so that's part of my answer. And then -16 divided by -4 is +4, and x squared divided by x squared is 1. 1 times 4 is 4. All right, I'll check again, make sure these 3 don't have any common factors. They don't. And then if I want to check my answer, I could use the distributive property. I could multiply -4x squared by y squared, and I would get the first term. Multiply -4x squared by -5y, I would get the second term. And the third term I could check, and I can see that these 2 expressions are equivalent. And I could check my answer by using the distributive property. All right, let's look at letter B. All right, we're going to factor, I know all 3 of these numbers are even. So I'm trying to see if the factors of 12 are 4 and 3 and 6, but I can't divide 26 by any number except, well, I could divide it by 2, only 2. So 2 is the only common factor as far as the numbers go. And then the smallest number of y's I can pull out from all 3 factors or all 3 terms is 1. So I'm going to divide every term by 2y. All right, so 12y to the 3rd divided by 2y. If I pull out one of those y's, I have 2 y's left. All right, -26 divided by 2 is -13. I had 2 y's, I brought out 1, so I have 1 left. And then 12y divided by 2y is +6. Then you check your 3 terms, make sure that they don't have any common factors, and they do not. And if I use the distributive property, I can prove my answer is true. All right, so 10 is my smallest number. 10 can't go into 15, but 5 can go into all 3 numbers. So 5, and then I have at least 1 m in all 3 numbers, and I have at least 1 n. So 15 divided by 5 is 3. 3 m's, take away 1 m is 2 m's. And I brought out my n, so I'm done with that one. 20 divided by 5 is 4. I brought out that m, and I brought out 1 n. And then negative 10 divided by 5 is negative 2. Of these 2 m's, I'm bringing out 1. And I took out that m, and so I'm finished. None of the 3 that's left have common factors. And if I use the distributive property, I could check my answer to make sure it's true. All right, so now we're going to factor the polynomials by what is called grouping. If it cannot be factored, indicate not factorable. So the very first thing I'm going to do is check for a common factor of all 3 terms. So all 3 of these numbers are divisible by 3 and y. Do you see that? So 3 and y, so I'm going to pull out a 3 and y. So 12 divided by 3 is 4. If I start out with 3 y's and bring out 1, I have 2 y's left. Negative 15 divided by 3 is negative 5, and y squared divided by y is y. And then positive 6y divided by 3y is positive 2. And there we go. All right, and letter E. Now that it says by grouping, you need 4 terms to group. So I'm going to be able to group with letter E because I do have 4 terms. So not all 4 of them have a common factor, but these 2 have a common factor and these 2 have a common factor. So that's what it means by grouping. So the common factor of these first 2 terms is an x. So I'm going to bring out an x. Ax divided by x is just a. Negative 3bx, take out the x, I get minus 3b. Now, what do these 2 terms have in common? They can both be divided by 3 and y. So I'm going to write a positive 3. So if I bring out that 3y, sorry. If I take away that 3y, I have a left. And negative 9 divided by 3 is negative 3. Oh my goodness, that should be a negative sign. And I brought out that y, so I have negative 3b left. So notice what happens in the parentheses, if you can still read it. A minus 3b is a common factor of both of these terms. So that means both of these terms are being divided by or multiplied by a minus 3b, which makes it a common factor. So I'm going to pull that out. And when I divide out a minus 3b from both of them, what I'm left with is these 2 parts put together. X plus 3y. And we're going to see that pattern happen over and over again, so you'll get used to how it's written. I wish I didn't have all those extra lines. There we go. But anyway, so we're going to start seeing this pattern where we'll have 2 parentheses that match exactly. So one of them will become one of our factors, and to get the other factor, you just put what's outside the parentheses together, okay? All right, so now we're going to factor using what we call the AC method. So when we have an equation written, if we have 3 terms, the first term is considered the A, the second term is considered the B, and the third term is considered the C. So do you see how this is putting A and C together? That means we're going to literally multiply A times C in order to create a polynomial with 4 terms. So let's see what that will look like. All right, so on number 7, before I even start with the AC method, I want to see what do these 3 terms have anything in common? What could I divide all 3 terms by? So I see that they're all even numbers and they all have a y. So 2y is going to be my greatest common factor. So I'm going to bring out that 2y. So 12y to the 3rd divided by 2y is 6y squared. And this would be negative 13y. Do you see that? And then this is 6 because we brought out that y, and 12 divided by 2 is 6. All right, so we're going to ignore this 2y. It's part of our final answer, but we don't have to do anything else with it right now. Whoops, what did I do? So now we're going to use the AC method. Now we're going to multiply our first term by our last term. So we're ignoring the 2y. So we're going to multiply 6 times 6. And I think your college instructor already started this the other day, introduced this to you. So 6 times 6 is 36. So we're going to write this trinomial into a 4-term polynomial where the two middle numbers need to multiply to give us 36 and add to give us negative 13. Okay, so let's think of our factors of 36. So 36, we have 1 and 36. We have 2 and 18. We have 3 and 12, right? We have 4 and 8. No, we don't. Yeah, no, 4 and 9, sorry, 4 and 9. All right, so is there any way we can manipulate any of these numbers so that when we multiply, we get positive 36, but then when we add them, we get negative 13? Well, these are the two that will give us negative 13 if we add them, and if we multiply two negatives, we get a positive. So our two numbers, so we have a product of 36, a sum of negative 13, and our two numbers are negative 4, negative 9. So basically, I'm going to rewrite that 2y every time. We're not going to do anything else with it. All right, so I'm going to rewrite this so that that middle term, I'm going to divide it into negative 4 and negative 9y. So I'm going to bring down my first term, 6y squared. I'm going to divide this into minus 4y minus 9y. Now, do y'all agree? Negative 4y combined with negative 9y is negative 13y. And then I'm always going to bring down the last term. All right, so now what have I got? I am going to group these. Let me change colors. So now, whoops, I'm going to solve by grouping. So I'm going to group these into two different sets of numbers, and I want to know, what could I divide these two numbers by? Well, I could pull out a 2 and a y, right? So let's just ignore that for a minute. I'm going to pull out a 2 and a y. Well, 6y squared divided by 2y is 3y. Negative 4y divided by 2y is minus 2. So now I'm going to see, what can I pull out of? What could I divide 9 and 6 by? Well, I could divide them both by a positive 3. Actually, I'm going to divide by a negative 3, and I'll show you why in just a second. All right, I'm going to pull out a negative 3. Now, what happens when I divide negative 9y by negative 3? I get positive 3y, right? And then when I divide a positive 6 by a negative 3, I get minus 2. So remember earlier when I said you're going to see this pattern over and over where what's in the parentheses will match? Well, that's why I ended up dividing by a negative 3, because I wanted to see, what can I do to end up with a positive 3y minus 2 in the set of parentheses? And I knew I could get it by dividing by a negative 3. If I divided by a positive 3, I would have ended up with negative 3y plus 2, which would be almost this, but not quite. All right, this takes a lot of practice, you guys. So what do we get? These are exactly the same. So one of our factors is what's in the parentheses. And then if I pulled both of those out, what would we have left? We're going to put together what's left. So 2y minus 3. And then remember at the top when we said we're going to ignore that 2y for a minute, as part of our final answer, we have to include it in our final answer. Here we're going to pull it down. And that is the final answer. We have factored using the AC method. Now you might have to watch that a couple of times, but that's a good one to practice. All right, I'm going to erase all this and we're going to do another one. All right, let's look at number 8. First of all, we're going to see, is there anything all three terms have in common? And the answer is no. 19 is a prime number. It's not going to help us to divide by 1. So we're going to do the AC method. We're going to multiply 6 times 3 and we get 18. So remember, you want two numbers that multiply to give you 18 and add to give you that middle number. Well, the middle number is 19. So what are the factors of 18 that will add to give me 19? Well, think about 18 times 1. 1 and 18. 1 times 18 is 18, and 1 plus 18 is 19. So we're going to rewrite that middle term into two terms. We're going to write 1x and 18x, okay? So we're going to bring down our first term, 3x squared, plus, it doesn't matter which one you put first. I'm going to divide this into 1x plus 18x. And then you always bring down your last term, okay? So you bring down your first term and your last term, and the second term becomes these two, 1x plus 18x is 19x. So now we're going to group, and now we want to see what do these have in common? Well, they both have an x, right? So 3x squared, take away an x is 3x. X divided by x is what? 1, not 0, it's 1. You can't just leave it blank when a 1 is all you have. Now, what can we divide 18x and 6 by? And kind of think about this one. You want those to equal each other, right? So can't we divide both of these by positive 6? And you have to write the plus symbol, because if you don't, that would show multiplication through everything, through that one here. But anyway, so 18x divided by 6 is 3x, and 6 divided by 6 is 1. And then what happened? These match perfectly. So one of our factors is 3x plus 1. Our other factor are these two put together, x plus 6. And we just factored it. That's the final answer. All right, number 9. So can we divide 3 terms by something? We can. They're all even numbers. So we're going to pull out a 2 first. So then we have 2y squared plus 3y minus 54. All right, now we're going to use the AC method. We're going to multiply these, which would be negative 108. So we want two numbers that's going to give us a product of 108 and a sum of positive 3. So, what could we do? I don't even know. I would divide 108 by 12, and what would we get? 9. Oh my goodness, that was such a lucky guess. So 12 and 9, I can manipulate 12 and 9 and get 3, can't I? Well, I know one of my numbers has to be negative, because a negative times a positive is a negative. So would my 12 be negative? Let's see, negative 12 plus 9, is that positive 3? No, that's negative 3. But what about this? 12 minus 9 is positive 3, and 12 times negative 9 is negative 108. So those are our two middle terms. Those are going to be our two middle terms. So what do? We're going to ignore this 2 for a minute. Let's just draw a red arrow or a red circle around it, so we'll remember it at the end. But for now, we're going to ignore it. So we're going to bring down our first term. Our first term is 2y squared. We're rewriting 3y to positive 12y minus 9y. Y'all agree that's still 3y. And then we bring down that last term, negative 54. Woo. Oh my word. Stop it. Go away. Let me get rid of that weird thing. That'll be my 5. All right, so now what do? Now we're going to solve by grouping. So we're going to say, okay, what do these two things have in common, and what do these two things have in common? Well, these both have a 2y in common. So we're going to pull out a 2y. Well, 2y squared divided by 2y is y. 12y divided by 2y is positive 6. And now we want to try to get this, right? So what can we divide both of these by? That's right, negative 9. Negative 9y divided by negative 9 is 1y. And negative 54 divided by negative 9 is positive 6. We did it. That's what we wanted to do. So one of these is part of our answer, y plus 6. The other one is we put these two together, 2y minus 9. And then don't forget that 2 is part of our final answer. Look at that. Every time we do them, it gets a little easier, right? Okay, I'm going to erase this. Everybody got it? Okay, we're going to do number 10. Do they have any common factors? Nope. So we're going to do the AC method. 6 times 5 is 30. We're looking for a product of 30 and a sum of 11. So factors of 30 is 1 and 30, 2 and 15, 3 and 10, 5 and 6. 5 plus 6 is 11. Yep. So we're going to say, bring down our first term, divide up that middle term to 5x and 6x. And we bring down the last term. It doesn't matter what those two middle ones, it doesn't matter what order you put them. So now we want to go, okay, now we're going to do grouping. What do the first two numbers have in common and what do the last two numbers have in common? Well, the only thing that these two have in common is an x, right? Well, 6x squared divided by x is 6x. 5x divided by x is positive 5. Now, that's what we have right here, isn't it? So what could I divide these two terms by to get the same number? Well, isn't anything divided by 1 itself? Because you want something over here, right? What's 6x divided by 1? 6x, and 5 divided by 1 is 5. Now that's a little strange, but now don't our parentheses match? Yes, they do. So part of my answer is 6x plus 5. And then when you don't need to divide by anything and you have what you started with over here, that means you have to include a 1. So my second term is, we put these together, x plus 1. And that's my final answer. And then your teacher the other night taught you about foiling, right? F-O-I-L, the first two, the outside two, inside two, and the last two. Well, guess what? If we FOIL this, we're going to get what we started with right here. Whoops. Did I stop sharing that? I think I did. Okay, sorry about that. I thought I turned it off. It's going to have a fit. All right, so if we FOIL 6x plus x, we get 6x squared. And then if we did the outside term, 6x times 1 is 6x, plus 5x is 11x. And then 5 times 1 is 5. So FOIL is what you did in college algebra the other night. I'm pretty sure you guys did that. I'm pretty sure you got that far. All right, so let's do number 11. All right, they don't have any common fact. Oh, they do have common factors. What can I pull out of all of those? I could pull a t, right? So then I have 5t squared plus 39t minus 8. Now I'm going to do my AC method. 5 times negative 8. Don't forget that negative sign is negative 40. So I want a product of negative 40 and a sum of 39. Well, that's got to be 40 and 1, doesn't it? I need a positive 39. So my biggest number has to be positive. So how about 40 and negative 1? Isn't 40 times negative 1 negative 40? And 40 plus negative 1 is positive 39? Yep. So these are our two middle terms right here. So we're going to bring down our first term. So let me get rid of this. There we go. We're going to bring down that first term. We're going to bring this in at the end, right? 5t squared. Then we're turning our two middle terms into 40t and minus 1t. You can write the 1 or you don't have to. That's up to you. Minus 8. And now we're going to see, okay, well, let's group them. So I could divide 5 and 40 both by 5, and I can pull out a t. So 5t squared divided by 5t is t. 40t divided by 5t is positive 8. And look how close this is to this, which means what do I need to divide these by? They're both negative, so I need to divide them both by -1. A negative divided by negative is a positive. Negative divided by negative is a positive. These two match exactly. So part of my answer is t plus 8. My other answer is 5t minus 1. And finally, I bring down that t that I pulled out at the beginning as part of my final answer. And there we go. Number 12. You always want this first term to be a positive, and the only way to do that is to pull out a -1. So we're going to go ahead and pull out a -1. So a negative divided by a negative is a positive. A positive divided by a negative is a negative, and a negative divided by a negative is a positive 2. So when we're done, we'll have to add back that -1 at the end. So now we're going to multiply. So if this is a 1, what's 1 times 2? 1 times 2 is 2. So I want a product of 2 and a sum of -3. So what two numbers multiplied give me 2 and add to give me -3? Well, the only two factors of 2 is 1 and 2. And if I make them both negative, I still get a positive product, but -2 plus -1 is -3. So I'm going to ignore this for a few minutes. Let me circle that so I don't forget that as part of my final answer. Oops. What is that? Oh my goodness. I made that really fat, didn't I? All right, so we're going to bring down our first term, 1x squared. Our second term becomes 2 of these numbers down here. So minus 1x minus 2x. And then we bring down our fourth term or our third term like that. And now we want to group them. What could I divide both of these by? I can divide them both by x. X squared divided by x is x. Minus 1x divided by x is minus 1. And then think about this. I can divide both of these by -2. So -2x divided by -2 is positive x. And 2 divided by -2 is -1. My parentheses match. So part of my answer is x minus 1. My second set is these two put together, x minus 2. And the last thing I do is bring down a negative sign or -1, either one. But this is my final answer. Right there. All right, so now it says, I've already written the answer is not factorable, but let's see why. So here we have a coefficient of 1. So 1 times 64 is 64. So are there any factors of 64 I can add to give me positive 8? So I need a product of 64 and a sum of 8. Well, I could think of 2 and 32, 4 and let's see, 16. Is there any way to get 8 from those? No. 6. No, 6 is not a factor. 8. The only two more are 8 and 8. So since these both have to be positive, there's no way I could add any numbers to get positive 8. So on Hogs, there will be a button that says not factorable. And so this one is not, in fact, factorable. There's no two numbers that multiply to give me 64 and add to give me 8. Okay? So you'll get that answer sometimes, and that's totally fine. Oh, let me erase all this stuff. All right, what can we divide all three numbers by? Well, they're all even. 38 doesn't have that many factors. It does have a factor of 4 though, doesn't it? Yep, 38 divided by 4. No, it isn't. Just kidding. No, so just a 2, just a 2. So let's divide them all by 2. So I have 6x squared minus, what's half of 38? 19. And then 10. Okay. So now we use our AC method. 6 times 10 is 60. So we want a product of 60 and a sum of negative 38. I don't know. So what are my factors of 60? I have 1 and 60. I have 2 and 30. 60 divided by 4 is 15. 4 and 15 cannot give me 38. 60 divided by 5 is 12. 12. Oh, I'm looking for 19. Oh, I'm sorry. Oh, I'm looking for 19. In my brain, I never changed that. Yeah, sorry, this is a 19 in the middle, not a 38. We factored out a 2, didn't we? So this will be negative 19. Okay, so look, it is 4 and 15. Yeah, because 4 plus 15 is 19. And so if they were both negative, that would still give me a positive 60 and a negative 15. Okay, so we're going to ignore our 2 for a minute that we factored out. We'll bring it back at the end. Now we're going to rewrite this. We're going to separate that middle term, turn it into negative 4 and negative 15. So we bring down our 6x squared minus 4x minus, oh, there's my x, minus 15x, and then bring down the last one, plus 10. And then we're going to group these. What could I divide these two by? I can divide them both by 2x. So 6x squared divided by 2x is 3x. And negative 4x divided by 2x is minus 2. And then I could divide both of these by, now remember, I want this first term to be positive because of this one. So if I divide this by negative 5, wouldn't that give me a positive 3? Negative 5. Negative 15 divided by negative 5 is positive 3x. And 10 divided by negative 5 is negative 2. So I did it. So one of our answers is 3x minus 2. The other one is 2x minus 5. And we finally bring down that 2 that we factored out. And that's our answer. All right, how many more? I'm tired. All right, 2 more. So I don't think we can't factor anything out. All right, so if we multiply 8 and 9, we get negative 72. So we need a middle term of negative 34. So we have 1 and 72. We have 72 divided by 2 is 36. Okay, so those are 2 numbers, 2 and 36. We want a negative number, so our bigger number has to be negative. We still get a product of negative 72 and a sum of negative 34. So we bring down 8y squared minus 36y plus 2y. That middle term always has a y, okay? I don't think I've emphasized that. And then we bring down our last term, which is minus 9. All right, what can I divide these by? 4y. So 8 divided by 2 is 2y minus 36y divided by 4y is minus 9. And then look, that is the same, isn't it? So we don't want to change it. So we're going to write plus 1. So 2y divided by 1 and 9 divided by 1. There we go. So we have one of our factors. One of our factors is 2y minus 9. The other one is 4y plus 1. And that's my final answer. What a messy mess. And then the last one is, here's a 1 and here's a 9. So can we factor anything out to get 9 with a sum of 9? I don't think so. Because the only factors of 9 are 1 and 9. We can't do anything with 1 and 9 to get 9. when we add them, right? And the other two factors are 3 and 3. So if we add 3 and 3, we get 6. So 16 is not factorable. That one's not factorable. Okay. All right, now really that's the end of the lesson. So for your homework, you need to get through 5R1 and 5R2. But let me write that down. You got to do 5R1 and 5R2. But I did want to introduce radicals because I have a feeling you're going to see them tonight in your college algebra class, and I just wanted you to have seen them before. So you're technically allowed to stop the video now if you want to, or if you want to be familiar with radicals in case your teacher introduces it tonight. Let me just talk about it for a few minutes, okay? So first of all, you need to be familiar with the term perfect squares. So all of these numbers on the right are perfect squares. These are perfect squares. Why is 121 a perfect square? Because 11 times 11 is 121. Why is 36 a perfect square? Because 6 times 6 is 36. Any number that is a product of another number and itself, that is a perfect square. Why is 64 a perfect square? Because 8 squared is 64. So that means the square root of 64 is undoing squaring. It's the opposite. That is 8. What is the square root of 100? The square root of 100 is 10. 196 is a perfect square. So what's the square root of 196? Well, the answer is 14, right? What's the square root of 49? Square root of 49 is 7. Okay, so you need to have memorized the first 15 perfect squares. Okay, it'll make your life easier if you just memorize the first 15 perfect squares. Go all the way up to 225. And you know most of them, I'm sure. So how do you ratify? How do you simplify a perfect square? Well, it's easy. If it's a perfect square, you just think of the number that times itself equals that number. So the square root of 289 is 17, right? So, however, you will not always get a perfect square, like the number 48. There's no number times itself that equals 48. So what you want to do is think, okay, well, 48 is not a perfect square, but does it have a factor that is a perfect square? Well, we can list the factors of 48. So I know that 2 times 24 is 48. 24 can be divided into 2 and 12. And I'm circling these numbers because they're prime numbers. 12 can be divided into 2 and 6. And 6 can be divided into 2 and 3, right? All prime numbers now. So 48 is equal to 1, 2, 3, 4, 2 times 2 times 2 times 2 times 3. All right, that's the same thing as writing 48. Now, you know when you go to a shoe store, on the top of the shelf, how many shoes do they show you? They show you one shoe, but when you get to the cash register, do you buy one shoe? No, you get a pair of shoes. So this is like saying, okay, well, I am going to, since this is going to be a little 2 right here, a number times itself equals 48, I'm going to circle each pair of numbers, and every time I circle a pair, I get to pull 1 out. So that 1 outside the shoebox represents 2 inside the shoebox, right? So here's a 2, I get to pull 1 out. Here's a pair of 2s, I get to pull out another one. And I don't have a pair of 3s, I get 1 3 by itself. So what's 2 times 2? 4, and 3 gets left under the radical because it's not a perfect square and there's no more factors of 3. Now, if I thought of 48 a different way, so anyway, this is equal to this. So if I thought of 48 a different way, I could have said, okay, I want to know what the factors of 48 are, but I want to see what the greatest factor of 48 is that is a perfect square. Well, if I thought about it long enough, I would realize that 48 is the same thing as saying 16 times 3. 16 is a perfect square. So now I can find the square root of 16. The square root of 16 is 4, and 3 is not a perfect square, so it stays under the radical. So I got that way, or thinking of it this way, okay? So let's do a few more, see, until we got it. Just to let you guys see some of these, okay? So they thought of it as the biggest number that's a factor of 48, which is 16. All right, what about 63? Well, 63, I could do the prime factorization. I could say, okay, well, 3 times what? 21 is 63, that's prime. Then I could do 3 times 7. Yeah. And then I'm done. So this is the same as saying 3 times 3 times 7. Well, I see a pair of 3s. So I'm going to circle 2, but I get to pull 1 out. And then 7 gets left in the box by itself. And that's the answer. Or I could have thought of it this way. What's the biggest factor of 63 that's a perfect square? Well, 9 times 7. 9 times 7 is 63. 9 is a perfect square. The square root of 9 is 3, and then 7 gets left inside by itself. So 2 different ways to get the same answer. Okay. All right, what about, oh, it agreed with me. 3 square roots of 7. All right, now when you have a problem written like this, you get to think of it as almost 2 separate problems, almost. Well, when I write it like this, hopefully you realize, oh, 16 is a perfect square. So I get to pull out the whole thing. There's nothing left in the box. The square root of 16 is 4. My denominator is 4. But now I got to deal with this square root of 75, excuse me. Well, the biggest factor of 75 that's a perfect square is 25. I know that 3/4 make up 75 cents, right? So 3 times 25 is 75. 25 is a perfect square. What's the square root of 25? Square root of 25 is 5, and 3 gets left under the radical by itself. So square root of 75 is the same thing as 5 square roots of 3. 4 is a perfect square, or excuse me, 16 is a perfect square, and the square root of 16 is 4. So that would be the final answer. Yep, we are right. All right, now they'll also show you variables, right? So we know that 16 is a perfect square. So we could rewrite this as 16 is 4 times 4. And then I see y times y. So think about the shoes situation. For every pair, I get to pull out 1. Well, I see a pair of 4s, I get to pull out 1. I see a pair of y's, I get to pull out 1. It represents both on the inside. And look, there's nothing left under the radical, so that's the answer. And the reason there's nothing left under the radical is because 16 is a perfect square, and so is y squared. The square root of y squared is y, because y times y is y squared. So 4y. All right, so what about 72? Well, we already talked about 72 is the same thing as 9 times 8, right? Did we talk about that? Maybe we didn't talk about that. 9 times 8. Well, in fact, 9 is a perfect square. So you might think, oh, it's 3 square roots of 8, but that's not true because 8 contains the perfect square of 4. Okay, so when I pulled out that 9, that's not the biggest perfect square. That's a factor of 72. So really, the biggest factor of 72 that's a perfect square is 36. 36 times 2 times a times a. And if you miss that, then if you list all those factors and pull out every time you have two 2's, you would end up getting 6 on the outside. Well, the square root of 36, this is like 6 times 6 is 6. There's 2 a's, I get to pull out 1. And what's left on the inside? What's left on the inside is a 2. And that's the final answer. All right, so I'm going to teach more about this next week, but I just wanted to introduce that to you. okay? I wanted, if you see it tonight in your algebra class, I didn't want that to be the first time you saw it. So anyway, you guys can practice those. We can talk about them when you meet live. We can do the rest of them if you want to, or you can wait until next week when we have the full lesson. That's almost the full lesson. We almost finished it. But anyway, so hopefully that helped. And I'll be live at 6 o'clock tonight. You can join me at 6, or you can wait till 6:45 or whatever. If you don't have any questions, you can just see me next week. So it's up to you. Everybody have a good day. I will see you later.